Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. Today we're going to learn about transformation and its first rigid motion, which is translation. So, what is transformation? Transformation is an operation that maps an original figure called pre image onto a new figure called the image. On the graph to the left, you will see here I have two triangles. Triangle ABC right here is the pre-image, and the image here is triangle A prime, B prime, and C prime. That notation means it's a prime. A transformation can change the size, orientation, and or its position of a figure. Okay, so there are several rigid motion that we're going to learn, and today we're going to start with translation. Translation is like a movement vertically or horizontally. It is the coordinate is represented at x plus h, comma y plus k. The h represent the horizontal translation or movement, and the k represent the vertical translation. So in this triangle here, I have triangle ABC, and this is the pre-image, and it moves how much? 1, 2, 3, 4, 5, 6. When 6 to the right, so the value of h here is positive 6, and goes down by 1, 2, 3. So the k there is negative 3. Okay. So that's how we define the h and the k based on the movement from pre-image to image. So let's shoot for this example here. Rectangle QRST with vertices negative 6, negative 1, negative 3, 1, S is 1, negative 5, and T is negative 2, negative 7. So negative 6, negative 1 will be 1, 2, 3, 4, 5, 6, negative 1. So this is my Q. R is negative 3, 1, negative 3, positive 1. That's my R. My S is 1, negative 5, 1, 2, 3, 4, 5. This is my S. And T is negative 2, negative 7. Right here is my T. So this is a rectangle. I'll connect them. There you go. So now I need to move or apply the translation. And it says here x plus 5, comma y plus 7. So the value of h is 5, the value of k is 7. That means I'm going to add 5 to the x coordinate of each point of from the pre-image. So let's go with in q, negative 6, negative 1. I'm going to add 5 there. That will give me negative 6 plus 5 is negative 1. For the s is negative 3 plus 5 is 2. I'm wrong. For the R, negative 3 plus 5 is 2. For the S, 1 plus 5 is 6. For T is negative 2 plus 5 is going to be 3. Now, while for the K is 7, that means I'm going to add 7 to the vertical component or coordinate. Negative 1 plus 7 will be negative 1 plus 7 is 6. 1 plus 7 is 8. 5 plus 7 is 2. Negative 7 plus 7 will be 0. And there you have it. These are the 4 points or the vertices of our image. So let's shoot and plot the points. Negative, let's use a different color. Negative 1, 6, negative 1, positive 6, 1, 2, 3, 4, 5, 6. So this is my Q prime. R is 2, 8, 2, 8, 1, 2, 6, 7, 8. So this is my R prime. 6, 2, 1, 2, 3, 4, 5, 6, up to right there. That is my S prime. And for my T prime, 3, 0, 1, 2, 3, 0. This is my T prime. And I will connect them all. And there you have it. The Q has moved 7 up because y plus 7 and 5 to the right. And all the points did the same thing there. There you go. A vector is represented in the coordinate plane by an arrowhead drawn from an initial side, initial side, or initial point, which is P, to the terminal point, which is Q. The vector is denoted as vector PQ, and the component form of a vector is written as A, B, where A is the horizontal component and B is the vertical component. The component of vector to the right, which is right here, this is not the right, in this example here, is from P to Q. So A talks about the horizontal component. So 1, 2, 3, 4. So this will be 4. If you notice, not a parenthesis, it's like a less than sign. And then this will go up by 1, 2, 3, 4, 5, 6, 7, 7, and like a close vector or a greater than. All right, let's find the vector component of the example here. So you start at W, go to V because I see the arrowheads right here. So going to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know this will have a 9 there and it's go up by 1, 2, 3, 9, comma 3. For A and B, the arrowheads right here. So you start at B. So you go 1, 2, 3, 4, 5. So that goes to the left. So that's negative 5. And go up by 1. So comma 1. And here you don't need to go left or nor right. So that's 0. But you need to go 1, 2, 3, 4, 5, 6. Very simple, right? Now, what if you're given a triangle STU with the vertices negative 4, 2, T 5, negative 1, and U negative 2, negative 2 with with the vector component of negative 1, negative 5. That means the negative 1 is a horizontal component or it shifts to the left by 1. So you need to subtract 1 to your x coordinate. And the negative 5 means you go down by 5 to your y coordinate. Okay. So again, the S is negative 4, 2. So I am going to subtract 1 and I'm going to subtract 5 to the y coordinate. So negative 4 minus 1 is going to be negative 5. 2 minus 5 is going to be negative 3. That's my S prime. For the T prime, 5 minus 1 will be 4. And negative 1 minus 5 is going to be negative 6. U is negative 2 minus 1 is negative 3. And negative 2 minus 5 is negative 7. Okay, so let's plot the points of our pre-image for the STU. Negative 4, 2, negative 4 up to here is that's the S. T is 5, negative 1, 5, negative 1 right here is the T. And the U is negative 2, negative 2. It's U right here. So if I connect them, let's say this orange one here. And then there's a translation using the vector here, negative 1, negative 5. So the S prime will be negative 5, negative 4, negative 5, down 3. So 1, 2, 3. Very good. That's the S prime. T is 4, negative 6. 4, negative 6. So 2, 4, 6. This is the T prime. And for the U is negative 3, -7, t prime. This is the u prime. I mean u prime. So therefore, we connect them. Boom, boom, boom. So there was a movement from S, a -1, left -1, and down 5, left 1, down 5, left 1, down 5. Okay, there you have it. And that's how you move or transform figures using translation, identifying the component of the vector, and applying the vector in translating our pre-image. And as always, boom.